Welcome to the fourth and final week of the course. We'll talk about two topics. First, how to manage variability of renewable electricity generation. Second, how mathematical models are used to quantify trade-offs between different options in planning the transition, and what to look out for when interpreting reports and studies based on such models. This is an overview of the 5 modules this week. The final lecture will be given by Francesco Lombardi, an experienced energy system modeler here at TU Delft. For the first 3 modules, we will focus on how to deal with variability. We said last week that solar and wind generation, despite their variability, are the most likely sources of large amounts of climate-neutral electricity. Now, we will look at the 3 main ways through which we can make a system built around them work. So, 3 ways to deal with variability: grids, storage, and flexibility. As a reminder from last week, on an electricity grid, demand and generation of electricity must always be perfectly balanced. So if we are thinking of time series again, our job is basically to get the 2 time series, the demand time series and the generation time series, to overlap. To achieve this, we can either change the generation time series or the demand time series, as we will see. We can roughly divide the variability problem into 3 separate subproblems based on the timescale of variability. The hourly problem is more or less solved. And that's good because we are already at the point in many countries where enough renewable energy has been deployed to make this a relevant problem to address. Right now, the somewhat harder problem of single days and the day-night cycle for solar energy, up to several days of bad weather, is not yet critical in most parts of the world. It is also mostly solved, though more research to work out the details is still needed. Finally, the hardest problem, longer-term variability, months to seasons, is mostly unresolved. But that's okay, we are still quite far from the share of renewable energy in total demand, where this will really be a critical issue. Many viable options are being developed and tested. Okay, so we have these 3 problems, and we have 3 possible solutions. Let's go look at this in more detail, and to do that, I'll see you in the first module.